Hello guys, I hope you all are doing good. I'm Vaishali Kikan and we are discussing the digital circuits. Today in this video, we are going to talk about the binary codes. We are going to start our discussion upon the various codes. So this is an introductory video of the binary codes. We are going to see what are the binary codes, what are the different properties of the binary codes. At last, we will be seeing the different types of the binary code, the weighted code, non-weighted code, reflective code, sequential code, error detecting and the correcting code, and the alphanumeric code. All of them we are going to talk in detail. We are going to see the introduction of all of them and we will be having separate videos on all of them as well. So this is a basic building block video where you are going to understand various things about all of the types of the binary codes and what is a binary code that you are going to understand in this video. So let's start our discussion with understanding the binary code. Binary code is a symbolic representation of some information. Now this information can be in the terms of numbers, alphanumeric symbols, or some special characters or some control characters. So we are going to have the input, which is the information. We are going to convert it into the symbols with the help of the codes, right? So now a very beautiful example of that is a movement of the lift. So when the lift is moving, the floor is changing and the direction of the lift we also must know. The lift is moving in the upward direction or the downward direction. So the direction of the lift is represented by the arrow. This is a representation of the movement of the lift, right? This is a symbol. So again, it's a code. Now the floor of the lift is also represented by a number. So this is also again a code. So I hope you understood how any information can be represented with the help of the binary codes. So now I can have the information in the form of number, alphabet or word. These are represented by the specific group of symbols. So when I represent any number, alphabets or symbols with the group of symbols, then this process is called as encoding, right? And the symbols are called as encoded symbols, right? So now here the code. What is the code? Code is a group of symbols that are used for the encoding process. So now I hope you understood what is the code and what is a symbol, right? So now coming to the bits. What are the bits? Bits are in the form of zeros and ones. So if I have a binary data can be represented, it can be stored, and also it can be transmitted in the forms of zeros and one, that is the binary digits, and these binary digits are known as bits. So if I have a binary code, binary codes will be represented by the group of bits only. If you are given a binary code is represented in the form of zeros and ones. So I hope you understood as of now what is a binary code. When I was saying the lift was moving up and down, the arrow is not in the form of 0 and 1. So arrow is not a symbolic representation of a binary code. Now the floor number is also represented in the form of 1, 2, 3, 4, 5 and so on. So floor is also not represented in the terms of binary code. Binary code will be having either 0 or 1 or both of them, right? So the binary code are represent any number, any letter, alphabet, special character or the control function, as I have already told you. Now we can have two types of binary code. Binary code are broadly classified as a numeric code. Numeric code, as the name suggests, it represents the number. Then it is represented in the form of alphanumeric code. This is the second classification of the binary code. So alphanumeric code represents characters, alphanumeric letters as well as numbers. Both are represented by the alphanumeric code. Now these are the various classifications of the code: weighted code, non-weighted code, reflective code, sequential code, alphanumeric code, and the error detecting and the correcting code. So if I talk about the weighted code is further classified into binary code and the BCD codes. Binary code, we all know, it is represented in the form of zeros and ones. If I have any number, I know how to convert decimal or any other number into the binary number. If I convert it, if I represent it, it would be simply binary code. Whereas we are going to talk in detail about the BCD code. It's a special type of code which is represented in the form of zeros and ones. So we have 8421, 2421. We have various types of BCD codes. So these are two simple example of the BCD codes, right? Then we have the non-weighted code. Non-weighted code are the access 3 code, gray code and 5-bit BCD code. So we are going to talk in detail about the access 3 and the gray code as well in the upcoming videos. Coming to the reflective code is 2421525211 and the access 3 code. Sequential code is 8421 and the access 3 code. Alphanumeric code is a sky code, EBC, DIC code and the Hollerith code. Error detecting and the correcting code are the parity code and the Hamming code. So these are the various types and the examples of the code. Coming to the binary code representation. If I have binary code representation, I can use any number of bits for the representation. Whereas for the BCD codes, I was using only 4 bits to represent any number from 0 to 9. I can take the number 0 represented by 4 bits. Right, I can take 1, it is also represented by 4 bits. So in this manner, I can represent the BCD code by only 4 bits. Any digit from 0 to 9 is represented by 4 bits, right? So 9 is represented as 1001 in 8421 code, right? Now this is the 8421 representation. Okay, now this is a very simple representation, but if I have the binary code can be represented by any number of bits. So now 1 can be represented as simply 1 only, or 1 can be represented as 0, 1 only, or 1 can be represented as 0, 0, 1 only. So this is the basic difference between the binary and the BCD code. If I have now signed integer or the integer fraction, they are now using the floating point number representation. We had already talked about them. So if I have sign representation, we can be using, if I have a negative number, we can be using sign magnitude representation, 1's complement or the 2's complement representation. So now we have the broadly classification as the integer representation and the fraction representation. Integer is represented by first sign bit, then the magnitude, and then the implied radix point. Right, the fraction is represented as a sign bit, implied radix point first, and then the magnitude. So this is the basic difference between the integer representation, the floating point representation for a binary number. Coming to the weighted code. So now the BCD code is a weighted code. So it obeys the positional weighting principle. So what is the positional weighting principle? Each position is having a specific weight. So if I say a decimal number 565, so in this decimal number the 5 will be having the positional weight of 100. So now 6 will be having the positional weight of 10 and 5 will be having the positional weight of 1. So this is the decimal representation. Then 8421 code. In 8421 code we have 9 represented as 1001. So now here this position is representing the weight 1, this position is representing the weight 2, this position is representing the weight 4, and this position is representing the weight 8. So in this manner, every position is represented by a specific weight in the weighted code. Now 4-bit group will be having sum of weight is equal to decimal digit. So you can see here, when I was representing 9 in the 8421 code, so here 8 plus 1 is equal to 9, right? So if I add the weight, it will be equal to the actual decimal number. So here 1 was at the position of 8 and 1 was at the position of 1. So if I have to represent 6, 6 will be represented as 0, 1, 1, 0, because here 4 plus 2 will be equal to 6. The weight are added and it will be equal to the decimal number. So weighted code now can be classified as the positive weight code and the negative weight code. Any position can be having the negative weight as well. So 84 minus 2 minus 1 weighted code can also be there. So weights are in negative as well. So this is known as the negative weighted code. So 9 can be represented in 8421 as 1001 and 5421 as 1100, because here we have the position weight 5, here we have the position weight 4, 5 plus 4 is 9, so here only we can take 1 and rest 0. So 3 in the 8421 can be represented as 0011 because 2 plus 1 is 3, in 5421 also as 0011. So now coming to the non-weighted code. Non-weighted code do not obey the positional weighting principle and the digit position will not be having a specific value, right? So we can have any representation in the non-weighted code, like we have access 3, gray code, 5-bit BCD code, all of them are non-weighted code. At every position, like here I was specifying at this position the weight is 1. In the non-weighted code it is not possible to denote the positional weightage. Now coming to the reflective code. Reflective code are also known as a self-complementing code. Why they are known as a self-complementing code? Because the 9's complement of the n code word will be equal to the interchanging by 0 to 1 and by 1 to 0. So if I see the representation of 9, if I see the representation of 0, both of them are complemented. If I see the representation of 1, if I see the representation of 8, both of them will be complemented. How we can complement? We can take any number and we can represent 0 to 1 and 1 to 0. So, right, if I have 2421 code, which is a reflective code, so reflective code 2421, here 9 is represented as 1111. So, 0 is the reflection of 9, right? So, 9 minus 0 is 9. So, here you can see 0 is the reflection of 9 and we can represent 0 by interchanging 1 to 0, right? So, all of 1s are converted to 0. Similarly, in the 2421 code, 5 is represented as 0101, right? And what is the complement of 5 or what is the reflection of 5? 9 minus 5 is 4, the reflection of 5 would be 4. How I am going to get the code word of 4? By replacing 0 to 1 and 1 to 0. So, code word of 4 would be 1010, right? So, in this manner, we can represent the reflective code. But when should a code be reflective code? It will be a reflective code when sum of all of the weight is 9. So, you can see over here, 2 plus 4 plus 2 plus 1 is 9, right? So, here this code is my reflective code. Coming to the sequential code. Sequential code is the next type of code which has numerous applications. Why it has numerous applications? Because the succeeding code word is one binary number greater than the preceding code word, right? So here if I have 00, after 00 I have only one bit change, I can represent 01. After 01, if I have only one bit change, so I can change this 0 to 1 and I can represent 11. Now after this one bit change can be represented as 10. So this is how we are moving in the sequential code. So succeeding code word, you can see if I move from here to here, only one binary number is increasing. Here if I am moving from here to here, only this 0 is converted to 1. Here if I move from here to here, this 1 is converted to 0. Coming to the alphanumeric code, right? So I was telling you about the various applications of the sequential code. Why it has various applications? Because of this property, and it aids the mathematical manipulation of the data, and this is the reason we can use it in the designing of the flip-flops, in the simplification of the K-map and all. So this is of the utmost importance and we are going to learn it in a separate video. Then the alphanumeric code. Alphanumeric code, as the name suggests, it will be having numbers plus alphabetic characters. Both of them can be represented. So a very basic example of the alphanumeric code is the ASCII code and the EBCDIC code and the Hollerith code. EBCDIC is used in the IBM processors only, whereas ASCII code is a universal code. It represents symbols plus it also represents instructions for the information exchange, right? So coming to the error detecting and the correcting code, as the name suggests, this type of code has the power to detect any error. What is the error? If I am sending some bits, the bits 0 can be changed into the 1 and 1 can be changed into the 0 in the channel. So due to the noise, the transformation is happening and this transformation is called as error. So this code has the power or capability to detect the error. So data integrity is maintained by adding some extra bit which is known as the parity bit. So now error detecting and the correcting code is having the code word plus the parity bits. Parity bit are the additional bit which is used for detecting the error as well as correcting the error. So extra bit are used for the error detection and correction so that integrity of the data will be maintained. So I hope you understood all of the types of the codes, and now in the next video we are going to talk in detail about the BCD codes. So join me soon in the next video. Thank you so much. I hope you like this video. If you like it, please push the like button, subscribe to the channel, share it with your friends, and also give me your feedback. That is utmost requirement. Thank you so much once again.